Find the acute angle between the lines y equals 3x and y equals minus x. Okay, the thing to remember with these, I'm just going to go back to the unit circle, which we revisit so often because it's so important. So if I just draw a little unit circle. So there you go, there's our unit circle, but it could potentially be any circle with any radius. If we just go from the origin up to the circle, offer an angle, so we'll call the angle theta. The important thing to remember, the gradient of that line is tan theta. So tan theta is gradient of line. In this case, the red line, right? So we can apply that generally to lots of rules. If we know the gradient, then we know tan of the angle that it makes for the x-axis. So just going to draw some axes. And then we're going to draw y equals 3x and y equals minus x. So there's the y-axis. X-axis, I'll label those in a sec. Y equals 3x has a gradient of 3. It goes along 1 and up 3, along 1 and up 3. So if it starts from 0, 0, which it will, it's going to go along 1 and up 3 like that, and through here and so on. Back the other way, 1, 2, 3. 1, 2, 3, something like that. So y equals 3x will look like that. And y equals minus x, well, that has a gradient of minus 1 and it goes through the origin. So that's going to go along 1 and down 1, something like this, all the way to here, and it's going to go up the other way to there. Okay, so there we have y equals 3x and y equals minus x. So if I want to find the acute angle between them, well, you've got two angles between them really. You've got this angle here, or you've got this angle here, and then they'll just repeat. So you can see that we could call this potentially the acute angle x. You can see that that angle is less than 90 and the other one's a bit more than 90. Right, so what we can find very easily using the gradients, I can find this angle here. I'll call that alpha, and that's going to be, or tan of alpha is going to be 3 because tan of the angle is the gradient of the line, and the gradient of y equals 3x is 3. So tan alpha equals 3. We'll work out alpha in a minute. I can also work out this angle here, we'll call that beta, and that's, remember, tan beta is the gradient of the other line, minus x, so tan beta equals minus 1, and the gradient of y equals minus x is minus 1. So using this information, alpha equals inverse tan of 3 equals, make sure you're in degree mode. We are in degree mode, so that's good. So we want inverse tan of 3. So alpha is 71.6 degrees. Beta is going to be inverse tan of minus 1, which we could actually work out is from the unit circle. You should know that tan 45 or pi by 4 is 1. So this angle here is going to be minus 45 degrees. Beta equals minus 45 degrees. So looking at this diagram, you can see you've got angles on a straight line. All of this adds up to 180. So x is going to be 180 take away 45 plus 71.6. X equals 180, take away 45 plus 71.6. 180, take away 45 plus 71.6. and that gives us an answer of 63.4 degrees. If we just go back and look at the diagram, it looks reasonable.